Good morning, my name is Nicola Variante and I am the Head of Design Services in WinBuild. I'm a civil engineer with 20 years of experience in the design and construction industry. On the Riachuelo Outfall project, which is expected to be completed in early 2022, have been responsible for the development of an innovative piece of technology called the Risers Conce. Coastal cities are threatened by water pollution. Combined sewer overflows, direct runoffs and discharges pollute the coast. That is why, as cities grow, new outfall systems are required. Marine outfalls are gravity discharge systems that release treated wastewater into the environment. They include an outfall shaft, which provides the effluent with the necessary hydraulic head to flow along the tunnel, an outfall tunnel to transport the effluent offshore, and a diffuser section to uniformly release the effluent into the water. The diffuser section of the tunnel generally presents a variable cross-section to ensure the theoretical self-cleaning speeds. It also includes a series of vertical offtakes, the risers. The top of each riser is fitted with a diffuser head from where the wastewater is released and diluted into the final receptor. In some marine outfall projects, the installation of riser is performed offshore with various conventional marine operations that can include dredging activities, drilling and piling works. Marine works are particularly demanding in terms of safety, environmental and construction schedule. Moreover, the connection between the outfall tunnel and the vertical risers is particularly complex and represents a risky operation. There are at least two key drivers that highlight the need to develop innovative solutions for outfall projects: enhance safety during construction, reduce the environmental impact. In general, an outfall project requires extensive offshore work, including assistance from divers to perform complex fitting tasks and other special works, both inshore and offshore. As a matter of fact, offshore construction works and diving operations are unfortunately still affected by a large number of fatal injuries every year. Statistics show a high number of fatalities associated with offshore work and commercial diving. Another important aspect associated to marine work is the intrinsic environmental impact that this type of activity produces. To name a few: disturbance and suspension of contaminated sediments, water contamination, destruction of fish habitats, use of heavy equipment and CO2 emission. For the construction of the Riachuelo outfall in Argentina, a different approach was developed to mitigate this safety and environmental risk. The Riachuelo outfall was originally designed with conventional construction methods and included an offshore shaft, an outfall tunnel underneath La Plata River, an offshore shaft, and a shallow diffuser pipeline, including vertical risers. The diffuser was made of pipes with different diameters, placed on the previously dredged riverbed and set on piles. All of these would have needed considerable offshore works. The alternative solution that we eventually developed consisted in extending the outfall tunnel and inserting the vertical riser from within the tunnel. This eliminated the need for transition shaft, deep foundation on piles, dredging and backfilling activities, horizontal feed pipe. This solution, known as the riser concept, became an example of hazard elimination by design. This alternative that we proposed required the development of an innovative method to install the risers from inside the tunnel. The method allowed for the bottom-up installation of the risers from inside of the outfall tunnel by jacking the risers up to the seabed. Here is a short video that simulates the application of the riser concept of the Riachuelo project. Riachuelo includes 4 discharge chambers, 55 meter depth and 14 meter diameter each, from which a 12 km outfall tunnel with an internal diameter of 4.3 meter is excavated by a TBM, 35 meters below the water level. The last 1.5 km of the tunnel is the diffuser section, where 34 vertical risers are placed at a regular interval. The riser concept starts during the TBM excavation. 2 special tunnel rings must be installed in correspondence of each riser. The first ring allows the rotational adjustment to recover TBM roll, while the second ring includes the launching segment where an excavation head is pre-installed. After the completion of the tunnel, the riser jacking equipment is transported into place where the risers are to be installed. Once in position, the riser jacking equipment is supplied with riser segments. The initial riser segment is connected to the displacement head and jacking starts. Then, subsequent riser segments are connected to the previous one and jacked up one by one. To facilitate soil excavation, the displacement head was provided by a hydro-demolition system that sprays highly pressurized water at 300 bar. The last riser segment is then connected rigidly to the launching segment of the tunnel, and the riser bottom is plugged. Finally, the displacement head is then removed underwater and replaced by a diffuser head. As you can see in Riachuelo outfall, the method riser concept provides safer working conditions because several risky activities are no longer needed. Also, it eliminates several marine works that can cause severe environmental impacts. In addition, the method is very beneficial from a construction point of view. In fact, the construction schedule becomes more reliable, the quality of the works and the quality of control is improved, the cost of the overall project is reduced, disruption due to marine traffic are minimized. These following slides will show some of the construction details. The tunnel special rings have 2 main purposes. The first is to have a launching segment including a hole where the different displacement head is pre-installed. The second purpose is to ensure riser verticality by allowing rotational adjustment of the launching segment. The displacement head was fitted within a sealing system positioned on the edges of the hole in the launching segment. The segments were made of concrete with edge steel plates for ring connections. All the metal parts were made of duplex steel for durability requirements. The displacement head is a crucial element. The hydro demolition system was developed based on a testing campaign where geotechnical conditions foreseen on site were simulated. The displacement head comprises frontal plate with hydro demolition nozzles, discharge chamber where excavated material is collected, control valve and a soil discharge line to evacuate excavated material down to the tunnel. The displacement head was designed to be dismantled from up and to be replaced by the diffuser head after riser excavation is completed. The riser segments were designed to sustain forces and bending moments caused by jacking. No calculation methods are available to estimate jacking forces for upward jacking. The evaluation of the forces was therefore also verified by real-scale testing. A riser includes 18 segments of duplex steel tubes of 72 cm diameter and 18 mm thickness. Design of riser joints requires special care. The joint design had to satisfy a combination of requirements: rapid assembly on site, a smooth and continuous surface, watertightness of the joint, and at the same time high structural resistance and robustness. Construction tolerances of the riser joints had to be as minimum as possible to ensure watertightness and to reduce an accumulative inclination and deviation of the riser, while to ensure durability of the risers, duplex steel was used. The riser jacking equipment is not a simple jacking station, but is a movable plant that includes hydroelectric supplies and riser transfer system needed to operate two jacking stations simultaneously. A jacking station was provided by a truss platform with a 400 tons capacity and an active load distribution system to safely transfer the jacking load to the tunnel. The riser segments were picked from the riser transfer system and positioned on the truss platform by a riser handling device. The upper stabilizer of the station was equipped with a pipe brake to keep the riser safely in position when jacking is on hold. With adopting the riser concept in an outfall project, offshore activities are significantly reduced. In fact, the only needed activity is to remove the displacement head and install the diffuser head instead. The activity is done by two divers with the use of a small crane. The activity duration is very limited, and its influence is very local at the riser's position. Here is a short video that shows the operation of riser jacking inside the tunnel of the Riachuelo project. This alternative method led to the project being completed ahead of schedule. Moreover, during its execution, 34 risers were safely and successfully installed in about 50 days, which is less than half the time that was initially estimated. This result was above our expectations and confirmed the reliability and effectiveness of this innovative solution. The use of riser concept is not limited only to the construction of outfall projects. It can be extended to other applications where vertical shaft could be constructed from bottom up, rather than performing excavations from the surface. One example would be utility shaft or ventilation shafts. In congested urban areas, it would reduce the risk of disruption at street level. With this presentation, we now come to some important conclusions. The successful application of the riser concept in Riachuelo project proved this engineering innovation to be practical and beneficial. The riser concept takes us to a more sustainable construction technique, where worker safety is significantly improved and the impact on the environment is reduced. The method provides also advantages in terms of time, quality and cost. The riser concept represents a valid and proven alternative to standard construction techniques. It's an engineering innovation that changes the conventional way of building riser and represents a step forward in sea outfall technology. In some cases, innovation provides a tool which drastically changes the way things are done. The Fosbury flop is a good example of what I mean. Thank you.